Okay, so now we're going to look at how do I use law of sines to find a missing angle? Okay, and so we're going to think back to when we were using right triangle trigonometry, where we were looking at using a trigonometric ratio in order to find an angle. We looked at using the inverse, so inverse sine in this instance. So we're going to look at if we have two given sides and one of their opposite angles, how do we find the other angle or the other angle that's opposite of one of the sides? So I have a triangle here just to kind of give you an example so you're not just hearing those words. In this case, we're given two sides, 5.8 and 7.1, and we have an angle given to us opposite of 7.1, and it's 61 degrees and 50 minutes. So we're going to use law of sines to find out what is angle A. Now, we can do this because we know that 7.1 is larger than 5.8. We'll look at an example in which you would not be able to use it, but for now, we know for certain that 7.1 is larger than 5.8. Therefore, we know that the angle A has to be less than 61 degrees and 50 minutes. It has to be. All right. Well, cool. Now we have all the information we need. Let's set up law of sines so we can see how we have to solve for angle A. Well, as I've said before, when I'm looking for something, I like to put that in the numerator when I'm setting up a proportion problem. So I'm looking for angle A, so I'm going to say sine of A, so sine of angle A, divided by its opposite side, which would be 5.8, is going to be equal to sine of the other angle given, so sine of 61 degrees and 50 minutes, divided by 7.1. Okay. Well, how would I have to solve for A? Well, first and foremost, we know from algebra, in order to solve for this unknown, we first would have to multiply both sides by 5.8. So let's do that. Let's multiply both sides by 5.8. And so I get sine of A, and I'll actually write this on the next line here. We get sine of A is equal to, multiply both sides by 5.8, 5.8 sine of 61 degrees and 50 minutes divided by 7.1. All right, great. Well, how do we find the unknown angle? Many of you may recall that we can, in order to undo the sine, we would do the inverse sine. And so if we do inverse sine of both sides, we end up saying that A is going to be equal to the inverse sine of 5.8 sine of 61 degrees and 50 minutes over 7.1. And so just take notice of when you're doing this, because a lot of times people say that this is very confusing, this is very hard, because they see things written in a longer format. If you wanted to, you know what 5.8 is. You can find out what sine of 61 degrees and 50 minutes is, and you can multiply those two and go ahead and divide by 7.1. So you end up with just one number inside of here, which is completely fine. It is up to you. The main goal of law of sines, and for you understanding law of sines, is that you know how to set up this equation. After that, it is algebra. It is solving for the unknown. So the main focus of this video is that you know how to set this up. The supplementary part is that it's just to refresh on how to solve for that unknown. In this case, that unknown angle, you have to use the inverse function. So we have to use the inverse sine function in this case. All right. And so this we would plug into our calculator. We would do inverse sine of 5.8 times sine of 61 degrees in 50 minutes. I put my parentheses around that so I can keep it separated. And then divide it by 7.1. And when I do that, I end up with angle A is going to be 46 degrees 4 minutes and about 4 seconds. So I get 46 degrees, 4 minutes and 4 seconds. Okay? And so that's angle A. Now, again, this was because I was given two sides and an angle opposite of one of those sides. In this case, it was the larger side. If it had not been a larger side, I would not necessarily be able to solve for this angle. And we'll see why in a moment. But again, the main thing here is how do I set up this law of sines? So I have sine of the angle that I'm looking for divided by its opposite side is equal to sine of the angle that's given divided by its opposite side. And because I have that information, I can set up law of sines and then solve for the unknown. To solve for the angle, I multiply both sides by the given side. And then to get rid of the sine function, I use the inverse sine function on both sides. Okay? Well, let's look at that other example I was talking about for when you could not necessarily just do law of sines. And it'll be fairly simple. So I'll show this with the example. So let's say I have a triangle that has one side has a length of 1.5. Let's say the angle opposite of it is 32 degrees. And let's say I know that this angle is 2.5. Okay? Now I just drew this triangle this way. I have no way of actually knowing this is an obtuse triangle because I could have drawn this another way if I wanted to. Oops. I could have drawn 1.5 here instead. And if I had done that, this would have been an acute triangle instead of an obtuse triangle. And yes, these two sides definitely can be congruent, right? This could be a nice isosceles triangle drawn here. So I know that 1.5 can be in both of those places. But how do I know which triangle it is? Is it the larger triangle or is it the smaller one? Is it the obtuse triangle or the acute triangle? I don't know. And when I try to set up law of sines to find out, well, what is the angle opposite of 2.5? Is it this angle or is it this angle? I don't know. And when I set up law of sines here, what I end up getting is that I get sine of A over 2.5 is equal to sine of 32 over 1.5. Or I get that it's sine of Q. And so actually, what you'll see happening is that if you put this in a calculator, so you solve for A. So how would I solve for A? Multiply both sides by 2.5 and then take the inverse sine of that. And so I get that A would be equal to the inverse sine of 2.5 times sine of 32 divided by 1.5. And so if I were to do that, inverse sine of 2.5 times sine of 32 degrees divided by 1.5, I end up with an answer of 62 degrees. Well, let's say I knew for certain it's an obtuse triangle. That doesn't make sense for it to be 62 degrees, does it? Because that would be the obtuse angle. 62 degrees is not an obtuse angle. Well, how would I find the other angle? Well, actually what I would end up doing is I would subtract that angle from 180 degrees. So we got two possibilities. Either it's that 62, that acute angle, so 62 degrees, or it's the obtuse angle, which we get from subtracting 180 from this, and that's 118 degrees. One of these is true and the other one is false. How do I actually know what it is? I don't, unless I know what type of triangle is given to me. If I know this is an obtuse triangle and it's accurately drawn, So say if I'm out in the land, maybe I'm surveying a field that is in this shape, and I see that, no, that's definitely an obtuse triangle. Then I know that this would be the correct answer. Or if I'm in the same field and I see that it's definitely an acute triangle, I know that this would be the appropriate angle. But just given two sides in one opposite angle, if the angle is opposite of the smaller side, I don't know if the other angle should be acute or it should be obtuse. I have no way of knowing unless more information is given. For instance, if I see the triangle directly. So that's very important to know and to remember. So we've looked at how to actually solve for these angles given two sides and one opposite angle. If you're given three sides, you're good to go because you are set in stone that it has to be that type of triangle. If you are not, though, you're only given two sides and one opposite angle, you must be given the angle opposite of the larger one in order to know for certain what type of triangle it is. If you're given an angle opposite of the smaller one, you have two possibilities for what type of triangle. It's either an obtuse or it's an acute triangle. All right. Now I showed you this not to scare you, but just so you know there are two possibilities. You will know what type of triangle it is for any problems that you're given in the class. In some cases, and depending on your teacher, maybe they may say, "Hey, I want you to be able to tell me if it's going to tell me what both triangles would be if we don't know what it is." And in some cases, when you're surveying land, maybe this is the only information you could get. If you're doing some type of construction project or something where you have to actually find these other angles and sides, you have to show them the information for both triangles because you don't know. And it's better for you to try for one of them and you have a 50-50 shot. And if it doesn't work, then you automatically know, oh, it was the other triangle. It's our bad. We chose the wrong one because we didn't have enough information. But again, that's law of signs and using it to find a missing angle. It's very important to remember that if you're giving two sides and one opposite angle, you can use law of signs and definitely find out what the angle is if the angle that is given is opposite of the larger one. If it's opposite of the smaller given side, you have two possible answers, and you would need more information to know which one is the correct answer. All right. If you have any questions or extra comments on that, or you want me to clarify that even further, please leave a comment. So that way I can make sure that that's a lot clearer for you. Right now, that sums it up, and I will see you soon.